Hi, Chemistry 20. Welcome to what would have been our very first lab, collecting gases in the lab. So what we've done is kind of created a little bit of a lab investigation to go with this, which mimics in a way what you would have done in class. Unfortunately, you're not getting the actual practice, and there's not much we can do about that. The good news is that I hope you're planning on taking Chemistry 30. We do a lot of labs in Chem 30, and we'll have the chance to go through those next year. Now, the whole premise of how to collect a gas in a laboratory for the purpose of analysis is that gas, of course, is less dense than water. Water's a liquid. The particles are closer together. As soon as you have a gas of any type, the particles are spread out, which means that they easily go to the top. So ultimately, we have a scenario, something like what you see below on my slide here. A reaction happens in which a gas is produced. And as the gas is produced, it of course rises because it's less dense, and it travels along this tube. And we can direct where it goes, and the pressure of the gas building up will force it to go this way. And this is simply water. When the gas enters the water, it naturally rises to the top and is collected right here. Now, usually you'd have some sort of a way to measure the volume of the gas going up through that part. So there'd be little lines and stuff showing you the milliliters, etc. All right. So ultimately, this is called a water displacement method. Now, what you see in this picture is a lot more of what we would have done in class. The difference is that we fill up the big sinks in the lab instead of any sort of a basin or some sort of a beaker. But we would still use gas collecting tubes or a graduate cylinder like what you see here. And the way that we would generate the gas in the lab is we'd actually take little butane lighters and we'd put them underneath and bubble the gas up and collect it here, right? And then we can get the volume quite easily. Now, a key thing though, just to be aware for in terms of how this works, is once you've collected all the gas that you intend to, you have to move that cylinder up or down in order to perfectly adjust the level of the water to be even with the level of the gas. And the purpose of doing that is to make sure that the pressure in the room is equal to the pressure of the gas. So pressure will equal the pressure when we get those two even. All that you have is a barometer in the room in order to measure the pressure. That's what you use. So we need to make sure that we've equalized the pressure out here with the pressure inside that graduate cylinder. All right, let's keep chatting a little bit more about this process. Like I said, a barometer is what's used to measure it. And the one we have in the lab honestly looks a whole lot like this. It's sitting on one of the whiteboards and it's just against the wall there. And we can just look at it, no big deal, and measure what that is. Now, this one's measured in bars and millimeters of mercury. The one that we have in the lab measures it in kilopascals, which is, of course, convenient because that's what we use in our ideal gas law, PV equals nRT. The other thing that we do in the lab is we measure the temperature of the lab. Now, ultimately, that gas is getting bubbled up through the water. So we stick the thermometers in the containers, so in the sink, get the temperature, pardon me, of the water, and because the gas is bubbled through, the gas is going to basically be at the same temperature as that water is. Okay, it's not perfect, but it's really close. So ideally, the temperature of the water and the temperature of the lab, they'll match up. Okay, now the last thing, and honestly, for the lab investigation you do, we don't spend too much time on this. We do a lot more if we'd been in class, but we consider the pressure also of the water vapor that would have been present in the cylinder. When that water is bubbled through by the gas, some of the water also vaporizes. So we've got the gas in here, but we also have a little bit of water vapor too. So you can imagine then we've got the partial pressure of the gas that you collected plus the partial pressure of any water that vaporized. And that in turn is, of course, our total pressure, which works into Dalton's law of partial pressures. All right, there you have it, folks. You should have finished with the last lesson, our number 11, and now you can go to the lab, number 12. This one's a little bit longer, so spend some time on it, look through it, and there, folks, is the last podcast of the week. Have a good weekend, and I'll see you next week.